telephone, camera, jukebox, a map, and an alarm clock. These are all amazing inventions that changed the world, and today we carry all of them in our pocket. Even the best science fiction writers from 50 years ago couldn't have predicted how we live now. Mobile applications power our world. Millions of people use these applications every day without a second thought about how they're developed and what goes into creating them. But for mobile app developers, it can be a rough and tumble journey year over year as technology and tools advance daily. The devices they write applications for get more and more powerful. The tools they use continually advance, and this thrilling race results in exciting things that make our lives better. Today we're going to look at how all of this came together. Welcome to All Hands on Tech, where today's leaders talk tomorrow's technology. I'm Jeremy Morgan, and this is a history of mobile development. On March 7, 1876, Alexander Graham Bell obtained the patent for the telephone. Now, it's safe to say there's no way he could have imagined how we use these today. Not even close. Believe it or not, the idea of a portable telephone hatched earlier than most would expect. In 1917, Finnish inventor Erik Tigerstedt obtained a patent for a pocket-sized folding telephone with a thin carbon microphone. In 1917. Of course, at this time, electronic technology was nowhere near the point that anyone could produce one. But people had envisioned it. It wasn't until 1973 that a couple of engineers from Motorola made it happen. John Mitchell and Martin Cooper produced a handset capable of making telephone calls with no wires attached. It would be 10 years before it was commercially available. The Dynatac 8000X was released to the public. Now, this is the brick phone that you've probably seen in old movies from the 80s. You usually saw a Wall Street business person talking on them or someone incredibly wealthy. These were nowhere near mass adoption. Now, in the 1980s, several companies created mobile telephone networks in the anticipation of mobile phone adoption. They used a set of towers with antennas, and anyone within range of these antennas could communicate with the towers. This is similar to how standard radio communications work. However, phones are full duplex, meaning they receive and transmit simultaneously. Now, on maps, each tower and coverage area looked like a biological cell, which is why they were called cellular telephone networks, a term that we still use today. It would be another 10 years before someone invented a smartphone with applications on it. In 1993, IBM created Simon. It was a mobile cellular phone that could send email and had applications for notes and a calculator. IBM released it in 1994, but it wasn't a big hit, selling around 50,000 units. It suffered a lot of problems, but was pretty innovative for the time. Now think of the cadence here. Bell invents the telephone. 41 years later, someone has an idea to make it portable and put it in your pocket. 56 years later, someone creates it. Then 10 years after that, it's commercially available, and another 11 years later, and people are using it to exchange data. It was an amazing increase in pace. Today, 26 years later, it's estimated that 2.7 billion people have a smartphone. Ironically enough, we aren't using them for voice communication nearly as much these days. The explosive growth is due to the applications themselves. Now, the IBM Simon was impressive for its time. Transistors had become small enough that you could create a portable device capable of phone communication and data, making it a smartphone. But they weren't really called smartphones then. The term was PDA, or Personal Digital Assistant, and it was coined for these devices even though the waters could get muddy for a bit because most PDAs did not also act as cellular phones. The idea behind a PDA was something to help professionals be more efficient. They could create appointments, take notes, send emails or fax messages with these PDAs. They also worked as an address book for maintaining contacts. Business professionals were the target market here. While there was no way for the public to create applications for Simon, the applications were the selling point for the device. Some of the impressive features were a liquid crystal display with a touchscreen. It could make and receive cellular phone calls, could send and receive faxes. It contained an address book, a world time clock, calculator, and appointment scheduler. It also had a stylus, and you could take handwritten notes and save them. Pretty amazing. It's impossible to say how things would have went if the mainstream had adopted it, but we can assume at some point independent developers would have interest in building applications for them. But in 1994, I don't think many people were considering that. Now, 8 years after Simon's release, Another group called Research in Motion released the Blackberry. Now this is likely the first smartphone you remember. PDAs like the Palm Pilot enjoyed moderate success among professionals, but the Blackberry took it to the next level. It was a bona fide cellular phone and it could do so much more. The biggest selling point for the Blackberry? Wireless email. By 2002, email had taken off, both for businesses and society at large. The very idea of sending and receiving emails without being in front of a computer was pretty amazing. The Blackberry wasn't without its problems. It had a short battery life, about 30 minutes of phone calls could be made, and it took hours to charge it up. Also, the email functionality was there, but there were some issues. So back in 2002, I worked for a company that had managers that used Blackberries in the field, and occasionally we'd have them all overnight their Blackberries back to the central office to resync them with our Outlook server, and then overnight them back to their location. Fun times. But it was a huge advancement in mobile devices. The Blackberry was a phone that had a small keyboard attached to it. Now the little keys on the keyboard looked like the drupelets on a Blackberry, hence the name. And there was nothing like it for quite a while. By 2013, there were around 85 million Blackberry subscribers. The Blackberry used a modified version of the QNX operating system. This was a real-time operating system built for embedded devices. You may remember QNX back in the 90s as being the OS that could fit on a floppy disk, 1.44 megabytes. And we take pictures on our smartphones now that far exceed that. But this operating system allowed other developers to create applications for the Blackberry. Research in Motion released some SDKs for developers, and third-party applications were developed for the Blackberry. But it never really took off with the general public. And it wasn't for a lack of effort. RIM had released SDKs for the Java programming language, which was extremely popular at the time and still is. They made tools to develop applications for free and worked to get them in the hands of university students. And they provided excellent documentation and examples. The likely problem was interest. Blackberries were a business tool at the time, so third-party developers built B2B tools or found ways to integrate their company's services into the Blackberry phones. There weren't any people developing Angry Birds or photo editing apps. This was the early 2000s after all. Businesses had embraced Blackberries in a major way, but there were a few independent developers. Mainstream society hadn't adopted the smartphone yet. However, the writing was on the wall, and companies were scrambling to become the company that made the smartest PDA. Samsung, Sony Ericsson, Motorola, and of course Nokia were dominant in the mobile market. They wanted to beat Blackberry and make their phones smart enough to replace the PDA. Enter Symbian. Symbian was a computing platform for smartphones, though many people weren't calling them that yet. It was an operating system and a computing platform that contained a base OS that ran on ARM processors. Then it had a user interface as a shell on top of it. This user interface was customized for the phone or vendor. You could build applications for devices, but not without major issues. For instance, you could not easily port applications from one phone to another. And the same application across different phone manufacturers was even more effort for developers. It was a very fragmented ecosystem fraught with issues. Despite this, the phones sold well. In 2006, Symbian reached up to 67% of the smartphone market. Nokia ended up taking the lion's share of that, and they became the largest shareholder in Symbian and took control of the company in 2008. Symbian had a WebKit-based browser named S60. Now, many developers built applications that would work well within this browser. Other developers used C++ and the Qt framework to build applications for the platform. There were some downsides to the development process in these days. Developers had a choice of Open Programming Language, or OPL, and Symbian C++. Most applications were a combination of these not-so-user-friendly languages. If developers managed to learn these languages, they had to struggle with the inconsistent interfaces, as each manufacturer had their own APIs and their own way of doing things. Infighting between manufacturers meant a struggle to get things to work. Each had their own SDKs and things were just very scattered. Also, IDEs and access to SDKs were very expensive. These factors all discouraged independent developers. If a programmer wanted to build a fun app for phones like they do today, it was expensive and frustrating. Eventually, Nokia made some changes to their SDK. It was in C++, which isn't a user-friendly language. It used the Qt framework, which is well loved by developers and used to this day. That made things a little easier. But developers still had to struggle with inconsistent interfaces and creating multiple versions of the software for each phone. So while there was a Symbian OS development community, it disappeared quickly. Then something far more enticing came along. Everything changed on June 29, 2007. Apple released the highly anticipated iPhone. This gained massive media attention, and the phrase smartphone entered our vocabulary. The smartphone was familiar territory for Apple. They'd built PDAs in the past and made great technological strides with the Newton PDA. In fact, some people argue the term PDA came from the Newton itself. It was pretty successful sales-wise and technologically advanced. However, when Steve Jobs returned to Apple, he killed that project. He wanted them to focus on a new idea that became the iPod. Now, the iPod was very successful. And now Apple had created a device that had similar functionality to the iPod. You could download and listen to music on it. It also had the functionality of a PDA, and it was a cellular phone. All in one device. It was destined to be a hit. Now, in hindsight, we're able to see another factor that contributed to the iPhone's success. It had a 3.5-inch screen, a 2-megapixel camera, and came with 4 or 8 gigs worth of storage. It was practically a computer in your pocket. And it had a web browser. So before the iPhone was even released, programmers were asking about developing applications for this new phone. Everyone knew the potential of a computer in your pocket, and programmers wanted to build applications that would run on it. At first, CEO Steve Jobs didn't want to allow third-party developers to build applications for the iPhone. Known for his exacting standards and wanting complete control over the customer experience, he was very hesitant. Eventually, due to developer outcry, they reconsidered. Looking back, this choice may have been the biggest factor in the iPhone's success. It's impossible to say for sure. Shortly before its release in June of 2007, Apple announced the iPhone would run Web 2.0 compatible applications. They would allow developers to build applications that looked and felt like iPhone applications. Developers and users alike are going to be very surprised and pleased at how great these applications look and work on the iPhone, said Steve Jobs, Apple's CEO. Our innovative approach, using Web 2.0 based standards, lets developers create amazing new applications while keeping the iPhone secure and reliable. Web 2.0 was a drastic change in how we built web pages. Not long before the iPhone came along, websites were mostly statically generated. A set of pages you created and they weren't considered software. Software is what resided on your computer or laptop. But by the mid-2000s, websites became more dynamic and interactive. They were responding to user input and shared data back and forth with the user. The idea of a website being software took shape. A Web 2.0 website was software by any definition, and the folks at Apple thought that that would be the best way to get applications on their new product. Instead of building software on your phone, you built an interactive website. Then you would have an icon on your phone that points to the URL of a Web 2.0 page. Safari would load up that web page and maximize it, giving the impression that it was a true application on your phone. And developers were less than thrilled at the idea. They wanted native access, an application that actually lived on the phone. They wanted to access the full performance of the hardware and have their applications available offline. Not to mention the web still limited what you could do with applications, and developers demanded full access. In October of 2007, Apple announced that they would have an SDK, or Software Developer Kit, available by February of 2008. And by March, it had arrived. We're excited about creating a vibrant third-party developer community with potentially thousands of native applications for iPhone and iPod Touch, said Steve Jobs. The SDK was available for free to Mac users. It gave developers full access to the hardware and allowed them to access the iOS software through APIs. The SDK came with an iPhone simulator that replicated the look and feel of the iPhone device on your computer while developing. It was revolutionary and nothing like anyone had ever seen with a device. Apple created the iPhone Developer Program and the Apple Store, which was a marketplace for applications, so developers could build apps and distribute them and even sell them in a marketplace. And the first release of the SDK was rich with features. It included APIs for the core OS, core services, media, and Cocoa Touch technologies. The iPhone's multi-touch interface offered a user interface never seen before, and it had a ton of potential. Now, Cocoa Touch was a new application development environment for the iPhone. It uses a language called Objective-C. Now, Cocoa is a native development environment for OS X, so Apple created Cocoa Touch specifically for the iPhone and iPad. It included gesture recognition, animation, and other elements. And Cocoa itself is a collection of Objective-C frameworks. It was similar to a C shared library. Only it offers more functionality and documentation. While many developers first heard of Objective-C when iPhone development was created, it was far from new. Objective-C had been around since the early 80s. It was the language used for developing applications in the Next Step operating system. Next Step was a system used for Next Computer Inc., which was a company founded by Steve Jobs shortly after leaving Apple in 1985. Next Step was a unique system that used BSD Unix as a base with a mock kernel. It was a solid, fast operating system, and when Steve Jobs returned to Apple, the company was merged in. Next Step would later be heavily modified and become OS X. So Apple's relationship with Objective-C ran deep. Many developers were already using it for OS X, so it seemed like the natural choice for iPhone development, even though nobody outside that ecosystem had even heard of it. It was a mature and stable language with years of development and support behind it. Developers took to this language right away. Now, soon enough, the iPhone wasn't the only game in town. In 2003, a company in Palo Alto, Android Inc., was formed. It consisted of Andy Rubin, Rich Miner, Nick Sears, and Chris White. These guys were ahead of the game in many ways. Rubin described the Android project as tremendous potential in developing smarter mobile devices that are more aware of its owner's location and preferences. So long before the iPhone was released and mobile phones were smartphones, they worked on a vision to have smart devices in our hands. At first, they envisioned software for digital cameras. After they determined that the market was too small, they decided to take on the mobile device market, which was then dominated by Symbian, which we mentioned earlier, and Windows Mobile. We know little about this short period in history due to its secrecy, but between 2003 and 2005, Android Inc. had built something so amazing that Google acquired them for $50 million. We would later find out what that amazing thing was. By 2006, the public suspected Google was going to enter the mobile market. Based on acquisitions and the general knowledge that smartphones were going to explode in popularity, meant Google had to have something up their sleeve. And they did. They were developing a system to rival Blackberry, who was at the top at the time. However, when the iPhone was released, as we mentioned earlier, Google had to make a major pivot. The game had changed. Apple released its iPhone in June of 2007, and 74 days later, it sold its millionth phone. That's a heck of a head start. Google had an angle, though. They've always been a developer-focused company. They knew about the issues with smartphone app development up till now, the ones that I mentioned earlier. The different hardware, APIs, and scattered ecosystem stuff. Google decided that they would solve that problem and put the developers first. By creating an active developer ecosystem, they bet on the fact that more applications would create more phone sales. They bet the entire project on it. Google had acquired Android Inc. and made its founders employees. They originally had designed a phone with discrete buttons for a keyboard, much like the Blackberry. And they knew they'd have to go the touchscreen route eventually, so they began preparing for that. In 2007, Google joined the Open Handset Alliance. This is a consortium of technology companies and device manufacturers. Even chipset manufacturers were involved. The goal was to create an open platform for development, open source the software, and reduce friction for developers who created software for multiple devices. It's still active to this day. In September 2008, Google released the HTC Dream, or G1 phone. It ran the Android operating system and had a physical keyboard. This was the first smartphone that I owned personally. It was a great phone for its time, and it was exciting to see all of the innovation that they'd put into it. Now, learning from Apple's mistake, they immediately released the Android SDK version 1.0 with the phone. This included a full API developers could use to access to get to all the hardware on the phone. The API was designed to interact with Java, an extremely popular programming language. The Android platform enjoyed some advantages right off the bat. The Android market was available to distribute all their applications. They allowed publishing of applications without the long review process that Apple had already become known for. Longtime Java programmers could jump in and start developing applications immediately. There was a web browser available, and the Android operating system synchronized with Google services such as Gmail, Contacts, Calendar, and Maps automatically. It was very inviting to developers. An extra advantage that they still have to this day is the ability to develop Android applications on Windows, Linux, or Mac computers. To develop for iPhone, you still need a Mac computer. This lowered the barrier to entry for many developers. The first API was shaky but functional, and in February of 2009, Google released their first bug fixes to the Android SDK. The race was on for the best smartphone. Research in Motion, or RIM, was still around in the late 2000s, but usage declined after competing with Android and iPhone. As I mentioned earlier, they had 85 million subscribers in 2013, and that fell to 23 million by 2016. They struggled to maintain relevancy in this market. In 2016, they announced they'd stop making their own phones and instead focus on licensing. They refocused their strategy to building Android-based smartphones. While all this competition was going on between iPhone and Android, Microsoft wanted to enter the market. Now, the company was no stranger to this market. They'd been developing PDAs and mobile phones for decades, but the massive adoption of iPhones and Android phones minimized any success they had. Microsoft as a company was very early to this market. Way back in 1990, they began development of software for handheld computers. In 1996, they developed Windows CE for handheld devices. They had the Pocket PC in 2000. Windows Mobile was actively developed in the early to mid-2000s. Now, the folks that use these devices, mostly professionals, loved them. They didn't have a large market, but they had a happy market. The obvious advantage for Microsoft was building devices that could connect to their enterprise systems. Microsoft Windows and Outlook dominated the enterprise market during this time. So anything that could connect you to your Exchange server remotely seemed like a very natural extension. But regardless of how popular Microsoft products were in business, mass market adoption had eluded them. Windows Mobile progressed nicely through the years with a ton of innovation and great products. Things like Bluetooth file transfer and full integration with email, messaging, and Office applications were very popular. In 2004, Windows Mobile accounted for 23% of worldwide smartphone sales. It was projected that they'd beat Symbian and Palm OS to become the dominant smartphone maker. Their market share, however, peaked in 2007, and you can probably guess why it declined after that. Windows Marketplace for mobile allowed third-party developers to create applications, and the ecosystem flourished for a time. A big advantage Microsoft had here was the .NET Compact framework. This was a subset of the .NET framework, which was ubiquitous with developers in the enterprise. I spent a good chunk of my development career as a .NET developer. Windows application developers could use this compact version of .NET and write software against managed code. They could use C++, TCL/TK, Python, and other languages. Developers didn't have to start at ground zero. Now, another advantage was the integration with Visual Studio, which was a dominant IDE in enterprise. Folks like me who were .NET developers and worked with Visual Studio every day could just download some extensions and get to work. The SDKs were full-featured and easy to use. In 2009, Microsoft created Windows Marketplace for mobile. At that time, Windows phones only had a 15% share of the mobile phone market. They introduced a ton of great features to make your life easy as a developer. But it didn't help. By 2011, Microsoft's share of the mobile market had declined to 3%. And by 2012, the marketplace was closed. In 2015, Microsoft made one final push to get into the market. They released Windows 10 Mobile, which promoted increased synergy with Windows 10 for PCs. Microsoft created partnerships with Nokia and eventually purchased Nokia's mobile development division for $7 billion. Now, I had a Windows Lumia phone, and as a .NET developer, I had to try out mobile development. It was so easy and seamless, I can't even explain it. My .NET and Visual Studio skills transferred over, and I was able to make really cool things easily. I honestly thought as a developer that this would blow the competition out of the water, simply because it was so easy to develop applications that the ecosystem would soon fill up. It didn't, and the Microsoft phone was by all accounts a failure. In 2016, the program was discontinued and Microsoft laid off the Windows Mobile staff. It may have been a case of just being too late. iPhone and Android development has forged ahead, however. Fully realizing the potential of mobile development, Apple started working on a new and improved language for iPhone development. In 2010, Chris Lattner and several developers began work on Swift, a language that takes inspiration from Objective-C, Rust, Haskell, Ruby, Python, C#, and many others. Swift reached 1.0 in September of 2015 and was released with Xcode, the Mac developer IDE and platform. Now, Swift is wildly popular with iPhone developers, and the SDK has matured to a point where nearly anything you can imagine can be created for iPhones. And the language, libraries, debugger, and package manager are all open source. Swift won first place for most loved programming languages in the Stack Overflow Developer Survey for 2015. And it's safe to say that Swift will be the future of iPhone development for at least a few more years. And there had been a shift in the Android world as well. Dominated early by Java development, a company called JetBrains introduced a language named Kotlin for Android development. JetBrains is a software company started in 2000, most known for their development of IntelliJ, which is a smart IDE for Java. They now create smart IDEs for many languages, and they really know their stuff. They created Kotlin to be an industrial-strength, object-oriented language, and address some deficiencies that they saw with Java. However, they wanted it to be fully compatible with Java and use the JVM. Kotlin supports object-oriented programming as well as procedural programming. Kotlin 1.0 was released in 2016, and Google announced first-class support for Kotlin on Android in 2017. By 2019, Google announced that Kotlin was the preferred language for Android developers. And that's where we are today. iPhone and Android are the top two mobile platforms. But this history would not be complete without mentioning some other ways that developers build software for these platforms. Now, we've learned about native development mostly in this story. Objective-C and then Swift for iPhones, Java and then Kotlin for Android. A native application is one that's built and has binaries pushed to the device to be run. They either run against a Java virtual machine or iOS. It's the way to get the best performance from an application by speaking directly to the device or a VM. Things like games, graphics applications, and others need native performance to operate. However, there are applications that run in the web and have a Chromeless browser that accesses a web application. These are usually called WebView applications, and they've fallen out of favor recently. But a JavaScript framework called React, which was developed by Facebook, has taken over the web application world. Applications from small personal sites to giant enterprise apps are written in React. Facebook also created React Native to run on mobile devices. Now, React Native is written in JavaScript and is processed on the device and communicates natively with the platform. It's near-native performance with the ease of JavaScript, which really helps developers. Another thing to mention is Xamarin. While the Windows Phone may be a thing of the past, Microsoft is still in the mobile development game. Remember how I talked about how great it was to develop .NET applications on a mobile device? It's still possible. Xamarin was a company that started in 2011 by the engineers who created Mono, a cross-platform implementation of .NET. Mono gained popularity by allowing you to build .NET applications in Linux. The knowledge from all that work turned into the Xamarin tools to write native Android, iOS, and Windows Phone applications in C#. You build the applications in Xamarin, and it compiles to native code for those platforms. In 2016, Microsoft acquired Xamarin and integrated its tools into Visual Studio. So once again, we have that utopia environment for .NET developers. Though Windows Phone may be gone, development for iOS and Android are still going strong. The big advantages of Xamarin and products like it are pretty simple. They allow you to build a single interface and create performant applications one time, and then compile and deploy to both platforms. While it's not perfect by any means, it's an excellent solution for folks who want to develop applications that run at native speeds without having to do it in two different languages. I hope you've enjoyed this history of mobile development for this edition of All Hands on Tech. Though this episode focuses on the past, this podcast is where today's leaders talk tomorrow's technology. You can get transcripts and more information at pluralsight.com/podcast.